I'm going to skip got it problem number 4. If you would like to, the answer will be, for A, the answer will be after 8 years. And this is guess and check again. Answer for B will be after 11 years. So if you didn't understand the last example, you should probably go ahead and find the equation and test these two out. Now, right here, see this paragraph in this chart? That paragraph in that chart, go for this up above. What this paragraph in this chart are saying is, just like I told you before, you're never going to exactly reach $1,500. So if you were to graph it, you'd actually just have points. You would never connect them. That's what they're trying to say. So this whole paragraph is saying sometimes you can't connect. That's all this paragraph is saying. Sometimes you can't connect your points if you were to graph them. Alright, that's because it will never reach exactly $1,500 because it's year after year after year. Okay? Now what I really want to focus on is this part here. Alright? This is the part that I'm going to talk to you more about. And it is going to be how to make an equation given information. Alright? What this paragraph says, and you can read through it on your own, but here's what this paragraph says. To find the growth or decay factor, okay, you need 2 y values in order, which simply means in a row. Okay? I'm going to apply that on the next page. So let's go there and see what we can come up with. And this is going to be about linkses, or links, I guess, just links is plural. Problem 5, writing an exponential function, endangered species. This table, the one that I'm pointing at, this table shows the world population of the Iberian lynx in 2003 and in 2004. If this trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? So you guys can obviously see that it's going down, and we're going to use our general formula, okay? So here's what I would like to do with you. We need to figure out what the rate of change is. The rate of change is found by doing this. You ready? R equals. You take the 2 y values and you subtract them. So you take your most recent y value of 120 and you take away your oldest y value of 150 and you divide that by your original y value. Okay? So you take new minus old and you put that over old. And this is pretty neat. If you know things are going down exponentially, this is a really neat way, if you have 2 points, that you can come up with an exponential problem. Alright, so that is going to be rate equals negative 30 over 150, which is negative 0.2. Now this means that they are decaying. Can you guys kind of eye up that that means that they're going down 20% every year? Let's make our formula. This is step number 1. Step number 2 is to apply it. We need to figure out B. B is always 1 plus or minus. In this case, it's minus 0.2. So B in this case is 0.8. Alright, step 3. Y equals, how many were there initially? Initially there were 150. Okay, original times the 0.8 that we just got to the x power. That's making your equation. Now step 4. Ready? Step 4 said, what about 2014? Well, if, you ready? If 2003 is year 0, wouldn't 2014 be year 11? So we're going to take our equation and we're going to do y equals the original amount, our decay factor to the 11th power. And this is predicting, using old information, how many links there will be in 2014. So I do 150.8 to the 11 power. It's kind of sad, isn't it? If that is true, okay, if this is true and they do shrink by 20% every year, there's going to be approximately 13 left. So we can say that there will be approximately 13 Iberian links left. That's kind of scary. You know, it's always going to be decreasing, but look how it went from 115 down to 150 down to 13. Now, in 5A, they say, what about in 2020? Well, remember, 2020 would be year what? Well, if 2003 was 0, 2020 would be year 17. So I do y equals 150, okay, 0.8 to 17. So I'll do 150.8 to the 17. So there will be about 3 links left. So it's definitely shrinking very quickly, isn't it? Now part B, that's A, here's B. If you graphed this, would it ever cross the x-axis? They're asking pretty much, would it be negative? Okay, that's what it's asking pretty much. In other words, would it be negative? Well, I hope you guys know, no, you can't have negative links. Alright, that just means they're all gone. Okay, they're all gone. Right? And plus the fact that the x-axis is your asymptote, which means it's never going to cross it. Okay? That wraps up the lesson. What I would like to do with you very quickly at the end of this video is on number 1, I want to make sure that you understand the percent of increase or decrease. Now in number 1, you see how it's 0.45? Okay, this is where it's going to throw people off. You see how it's 0.45? This one would be a percentage decrease because it's smaller than 1. So you would do, I like to do 1 minus 0.45, or and you can do it the other way around if you want. You can do 0.45 minus 1. Okay, 0.45 minus 1 will be negative 0.55. The negative means it's decay, and the 55 is 55%. On number 2, see it up there? It was a 4 in parentheses. We should just make sure that you're okay, that if there's a 4 in parentheses, you do 4 minus 1, which equals 3, and you would say that that is a 300% growth, because it's bigger than 1. Okay? And I just do this because I know this is where students will struggle the most. On number 3, B was 3. Well, 3 minus 1 is 2, and 2 is bigger than 1, so it would be a 200% increase, or growth. I hope I'm doing an okay job explaining this, because it's pretty important that you understand this. And then number 4. Can you guys see in number 4 how it's 0.95? Well, that's smaller than 1, so I'm going to do 0.95 minus 1 equals negative 0.05. And since it's negative, that means it's a decay, and that is a 5% decay. If you have any other questions, go ahead and solve any of those, and let me know if you need anything.